Okay, today we're going to continue talking about molarity. So we're going to do a couple more practice problems, and then we're going to go into the lab and make our molarity solutions with, instead of Kool-Aid, we're going to do colored sugar. So just as a reminder, remember molarity is capital M for molarity, and that equals moles over liters. And so there we have our lovely equation, just to remember. And remember that we have to have these exact units to plug into our equation, or else it won't work. So let's go ahead, turn to page 4 in your packet and go to number 3. And we're going to go ahead and start here. So let's read this, and as we read it, let's underline our knowns and our unknown. Our knowns and our unknown. So for here, I'm just going to write down over here the different variables in our equation. And so we go ahead and read this. How many moles of KOH are required to make 250 milliliters of a 6 molar solution? So those are the things I underlined. And so now let's look and see which variables they coincide with. So moles, that would be with the moles, and we don't know what that is. Like, that's our unknown. We have 250 milliliters. Milliliters is going to correlate with liters because they're both units of volume. So in here, we're going to have to go ahead and we're going to have to convert this into liters. So we do that by using 1,000 milliliters on the bottom, 1 liter on the top. This is our conversion for milliliters to liters. So we divide 250 by 1,000 and we get 0.25 liters. So there's our liters. Okay, and we continue on. We have a 6 molar solution, so that's going to go right there at the top. So now if we look, we have everything in the correct units. We have molarity in the correct unit. We have liters in the correct units. We're trying to find moles, and so we're going to manipulate this equation right here. So in order to get moles all by itself, we're going to times liters by both sides. And now it's going to be liters times molarity equals moles. So here we have our liters, 0.25 liters. We're going to multiply that by molarity, and I'm going to go ahead and do the derived unit for molarity, which is moles over liters. And then we just multiply 0.25 by 6, and we get 1.5 moles. So that is our answer, 1.5 moles. And notice how our liters cancel. And that's how we know we have that mole unit, and so that is our answer there. Now remember, you can always plug back your information in and solve for something else. So for example, if we wanted to check to see if we did this right, we could say, okay, I'm going to solve for molarity. So I could take my 1.5 moles, and I could divide by my liters, which is 0.25, make sure it's in the correct units. And when we do that, 1.5 divided by 0.25, we get 6. And oh, look at that. That matches my molarity there. So it's so nice when you do equations because you can always double check to make sure you have the right answer. Okay, let's move on to number 4. So number 4 says what volume of a solution, so I'm going to go ahead, oh, that changed on me. Okay, let's try this again. What volume of a solution, that's our unknown, is required to make a 3 molar sample with 50 grams of NaCl. So again, I'm going to write out my 3 variables. Okay, first one we come across, volume of a solution, well, that's our unknown. And it just says volume, so we can just keep this in liters. We have a 3 molar solution, so that's our molarity. And then we have 50 grams of NaCl. Well, grams is going to correlate with moles because moles and grams are both dealing with an amount of a substance. So we're going to have to convert this to moles like we did yesterday. So remember that 1 mole of any pure substance is equal to the mass of that substance. So if I add up sodium and chlorine from the periodic table, I get 58.44 grams of sodium chloride, and that's equal to 1 mole. So double check my math, make sure that 1 sodium and 1 chlorine add up to 54.55. And when we divide the 50 by 58.44, we get 0.86 moles because now our grams of NaCl have canceled. Okay, so now that we have all the correct units, we have about molarity, moles, and liters. Now we just need to manipulate our equation. So we already manipulated it last time by solving for moles. So we know that moles is molarity times liters. So now what we're going to do is divide by molarity on both sides to get liters by itself. So now we have moles divided by molarity. So right here I already have moles. I'm going to divide that by 3 molarity, and I'm going to go ahead and break that apart into moles over liters. This makes our moles cancel. We're left with liters. So when we do that, we get 0.86 divided by 3, and our answer here is 0.29 liters. Okay. So once again, if we plug that in, like if we plug it in and say, oh, I want to solve for molarity, we go 0.86 moles divided by 0.29 liters, and we're going to get a molarity that rounds up to 3 moles per liter. Okay, I hope that helps. And if you have any questions, let me know. Have a great day.